right, well, I guess we'll find out what got missed. Or did I do something stupid by hitting stop instead of resume? All right, anyway, for those who are just tuning in, we've done box all around here. All right, units. Actually, let's not worry about units right now. So, are we done, other than units?
I feel like it's a trick question.
Let me just tell you, why are we not done?
Because we still need to find if it moves, and then we need to use the mu k.
Okay, kinetic coefficient. All right, so we've established that it's moved.
If the box is moved down the ramp?
Yeah, have we established that it will slide?
Yes.
Positive.
Yes.
Yeah, right.
Yeah. Or this is the driving force right here. This is what friction's trying to do. We haven't overcome it. All right, so we've established that it is going to move, and so now this now becomes K, and 0.3. So it's somewhere around 2.4. So I would expect the answer to be somewhere around 3.6-ish.
How did we get the 0.4 and 0.3?
I gave it to you.
Gotcha.
Basically with friction, I either give it to you or I give you enough information to find it.
Okay.
And Patrick, the answer is?
You said the UK was 0.3?
Yes. Oh, sorry. I thought you had already added. Wasn't trying to rush you.
3.549.
Okay. 3.549. Now we do need units.
Having a realization my phone can't be trusted to do any trigonometry. For some reason I get sine 37 is equal to negative 0.64.
That sounds like a radian issue.
It's not though.
Radians?
When I switched to radians, I got that. So
All right. Units?
I assume it'd be meters per second squared.
Yes. All right. Questions to hear? You can always borrow a calculator.
No, I'm just trying to figure. For some reason, when it says radians, it's in degrees, and when it says degrees, it's in radians.
Huh.
Do you have an Android phone?
Yes.
Yeah, mine's that way too. It's what you click to change it to.
It's
Oh.
yeah.
Okay.
Very smart design. Okay. I'm sorry for.
I sometimes wonder how much stuff is actually user tested. All right, I assume all of you are comfortable with this? I got 2 nods. 2.5 nods. All right, or 2 nods and a shrug. All right, so let's change it around. Let's see if I take that home or not. At what angle? So I start out with it flat. It will not slide because there's no reason for it to slide. I start lifting the angle very slowly. At what angle will the box start to slide? Now, I could have worded it differently. I could have said, at what angle, what is the greatest angle at which it won't slide? We assume that the angle at which it won't slide and the angle where it starts to slide are the same. They are close enough to count for physics. Maybe not for math purists, but good enough for physics. Force diagram hasn't changed. Matter of fact, the equations of motion would still be the same. That is not affected by anything. We're trying to find the first angle where it doesn't slide. Sorry, the first angle where it does slide, which is the same as the last angle where it doesn't slide. So we're using kinetic or static?
Static.
And what else changes?
Wouldn't the 0.3 change?
Oh, yeah,
Oh,
we're dealing with static. So what is it? You said 3 point something, 3.6?
the 3.54.
Okay, what is it now? The beauty of physics problems, where you're just supposed to read into it this time. This is the type of thing that typically they aren't gonna give it to you, and you just have to recognize the boundary condition.
Greater than 1,
What's greater than 1?
the acceleration.
No. You're using static. What does static apply?
Oh. To 0?
0. So in this type problem here, acceleration is 0. We assume that since we're at that last angle where it doesn't slide, it's not sliding, therefore it's staying where it is, acceleration is 0. So let's just get rid of this half over here. So we are now left with mg sine theta minus mu sy, which is mg cosine theta, equals 0. Do I have anything that I can cancel out? We can cancel out later too if you want.
mg.
Yep. If I divide everything by mg, including the 0, I'm left with sine theta minus mu s cosine theta equals 0. Again, trying to solve for theta, so I need to get all my thetas on one side. Oh, they are all on one side. I need to somehow get my thetas isolated.
I guess this is a job for trig identities.
Which trig identity do you want to use?
How do we deal with that u?
Well, that's part of what I'm asking you, but I'm hoping someone will realize it. Well, no, I don't want to spoil it for you. Might have to, but I don't want to. If you go the trig identity route, how would you do that? Which trig identity were you thinking?
I need to read the sheet.
Shall I spoil it?
I think you're gonna have to.
All right. If you're doing the trig identity route is a pain in the butt, first off. I mean, if you're going to think of sine squared plus cosine squared equals 1, that type of trig identity. If you're thinking tangent and sine over cosine, that'll actually be helpful. If I add this to both sides, then I get sine theta is equal to mu s cosine theta. Divide both sides by cosine theta. And mu s is equal to the tangent of theta. And so theta is just the arctan of mu sub s, which is 0.4. Which is something spectacular. Like 20-degree angle-ish. Very crude.
21.8.
21.8. And matter of fact, I mean, the people who come up with this stuff use more sophisticated equipment than we do, but in essence, that's the way you find it. These are all experimentally found. I want to know what is between aluminum and cardboard. I put it right there, I raise the track, and see at what point it starts to slide. So whatever that angle is, I take the tangent of it, and I have my coefficient of static friction. Find the coefficient of kinetic friction, I make sure it's going to accelerate. I figure out what that acceleration is, calculate mu sub k. So at that time I'll know A, I'm trying to find mu. Experimentally, they'll have better equipment than, just what I did right there, but that's the essence of it. Questions before I talk about a different way of breaking the weight up into components, and then we'll do the double incline plane.
What time do we leave the class?
4:50 is when we're officially done.
Okay.
I thought it was 4:40, at least on TechLink. Or student planning.
I have 4:50 written down here.
It would be the first time that student planning is wrong.
Because when we,
I think it is 4:40. At least that's what I've seen on Blackboard for our student times.
But usually they're 2 hours and 50 minutes long if it's a long form class. I don't know, it doesn't matter especially.
I mean, it's all fun.
Syllabus says 4:40, but I always assumed it was 4:50.
I always assumed it was 4:50 also. That'd probably be good to know. Then why don't you said it, you just looked it up?
At least the syllabus says 4:40.
Oh, the one I wrote?
Whatever is on Blackboard.
It does say 4:40.
Okay, I think that's my mistake.
Well, it
Pretty
also
sure.
says that when you go to student planning, like where you register. for
Student planning
courses.
says 4:40?
Yeah.
All right, it would not be the first time I missed something obvious, but if you'll indulge me then, and then we'll get it straightened out. How to solve for the breakup weight without having to go through the trig. There's some trig, but less thinking. Now when I draw it, it's a roughly 45-degree angle, and I'll just label it whatever it actually is. I'm breaking weight up. I know part of it is down the ramp and part of it is perpendicular to the ramp. Now, if I try to draw it more realistically, or even go to an extreme, if I'm under 45 degrees, I can just draw it much slighter. If it's more than 45 degrees, I can draw it like that. So let's just take the skinny one here. I'm breaking weight up, so weight is acting down this way. I know part of it is down the ramp and part of it's perpendicular to the ramp. Which one's bigger? The one into the ramp or the one down the ramp? Yeah. So I know it's gonna be, one of them is W cosine theta and the other one's W sine theta. You pop them both into your calculators, the bigger one is into the ramp and the smaller one is down the ramp. Over here, if we did that, if I have weight here that I'm breaking up, I'm going down the ramp and into the ramp. That's a right angle. Now, down the ramp's the bigger one. And in both cases, if I'm under 45 degrees, sine is smaller than cosine. If I'm more than 45 degrees, sine is bigger than cosine. Either case, sine is down the ramp. And the third way, in case your brain just happens to be working this way, if we take the extreme of it's flat, the angle is 0 degrees, well, sine is 0, so no ramp, nothing down it, and all the weight is into it. If it's at 90 degrees, cosine is 0, so there's nothing into the ramp, sine is all of it. In other words, it's in free fall. Why don't we end it there, either 5 minutes early or 5 minutes late, I'm not sure which.
All right. And you said you wanted master sets turned in on Thursday?
No, I have master set 4 due Wednesday.
Okay.
I said Thursday earlier because my classes are usually Tuesday, Thursday, or Monday, Wednesday, and I forgot what today was.
Alright.
Again, I'd be worried if I hadn't been doing that kind of stuff all my life.
Thank you for your counsel.
Oh, I understand.
You have a good one, Mr. Brown.
You too, see you Wednesday.